In this example, I'm going to solve this logarithmic equation. The reason it's a logarithmic equation is because I have my x part of some logarithmic expressions. There are two general types of logarithmic equations, whether I have the log on just one side of the equation or whether I have logs on both sides of the equation. And here I see that there are logs on the left and on the right, so it's this second type of equation. With this type of situation, what I really want to get to is the point where I have a single log on the left and a single log on the right, and then I can just sort of disregard the logarithms and set their insides equal to each other. So that's what I'm going to do. That means I'm going to condense these two logs into a single log. Also remember, since there's no base written, that's really base 10. That's not going to be important in this particular problem, but sometimes it is. What's important here is that this is a minus, so I have the difference of two logs. And the property of logarithms we have for that says instead of subtracting two logs, I can have the log of a quotient, which is a division problem. So I'm going to take the first logarithm, x plus 14, and divide by the second by 2. So I'm going to write a single log. I don't have to write a base, it's really base 10. I'm going to get x plus 14 all divided by 2. And then that's going to be log of 2x plus 3. And the idea here, since I have a log equal to a log and they're the same base, the only way for two logs to be equal is if what I'm starting with is also equal. So I just equate those parts and I forget about the logs. So I get x plus 14 over 2 equals 2x plus 3. And now to solve this, I probably want to get rid of the fraction, so I'm going to multiply both sides by the LCD, or the lowest common denominator. There's only one denominator here, 2, so I'm going to multiply both sides by 2. So I'm going to take 2 times x plus 14 over 2 equals 2 times this whole side. So I'm going to put it in parentheses, and that's going to make me distribute over here. Now, on the left-hand side, that's really 2 over 1, which doesn't really matter. It's just that those 2's cancel out. So I get x plus 14 equals 4x plus 6. This is a linear equation. I just have x to the first power, so I can just get all my x's together. So I'm going to subtract this x from both sides. So 14 equals 3x plus 6. Then I'm going to try to get the x by itself. I'm going to subtract 6 from both sides. So 8 equals 3x. And then I'm just going to divide by 3. And I'm going to get 8/3 equals x. What I need to do then is just check to make sure that this doesn't give me a negative inside any of the logarithms. Well, 8/3 plus 14, that's going to be positive. 2 is definitely positive. 2 times 8/3 plus 3, I don't know what it is, but it's definitely positive. So I don't have any trouble, and this would be my solution.